Today we're going to talk about radians, degrees, and arc length. First, we'll start with how to convert a radian to a degree. So I have an example here that shows that to convert from radian to degree, you take your radian measure and you multiply by 180 degrees divided by pi, and that will give you the degree measurement. I'll just go ahead and start with an example like number 1. So to convert 3 pi over 4 radians, you take your radian measure, so 3 pi over 4, and then we multiply by 180 degrees over pi. And if you do a lot of these calculations, what you'll notice is a lot of the radian measures do have a factor of pi. They don't have to, but a lot of times you'll notice that radian measures have pi, and that's because of the unit circle. So anyways, the pi factors cancel, and we would have 3 times 180 degrees over 4. 4 does divide 180 45 times. So 180 divided by 4 is 45. So this is equivalent to 3 times 45, which is 135 degrees. So they are equivalent measures. 3 pi over 4 radians is 135 degrees. Let's look at number 4. Number 4 has us do 11 pi over 6, and we're going to convert that. So 11 pi over 6 times the ratio of 180 degrees over pi. Again, you see that we have the common factor of pi, so we cancel them. 6 goes into 18 3 times, so into 180 30 times. So that leaves us with 11 times 30, which is 330 degrees. Let's look over here at number 9. We have pi over 12. So pi over 12. Same ratio, 180 degrees over pi. Our pi's factor cancel once again. 12 goes into 180 15 times. So this would just be 15 degrees. Okay, now let's look at converting degrees to radians. What's really nice is it's almost the same thing as the previous problems, but instead of multiplying by a factor of 180 over pi, we're going to just take the reciprocal of that. So we're going to multiply by pi over 180. So let's just start with number 1 here. We take our 90 degrees, and we're going to multiply by the ratio of pi over 180 degrees. So what happens here is the units of degrees are going to cancel because we're multiplying by a degree unit and dividing by a degree unit, so they cancel. And then 90 over 180, that's half, right? 90 out of 180 is half. 90 goes into 180 2 times, so this would be equivalent to 1 over 2. So this would be 1 pi over 2, or we just say pi over 2. Let's go and look at number 7 here. We'll do 450 degrees. Multiply by pi over 180 degrees. The degree unit cancels. And in our new answer, we're going to have pi. And 450 divided by 180, I believe they have a common factor of 30. So we'll start there. So if you divide both of these by 30, this would be 6, and this would be 15. So 15 over 6, which reduces once more. We could divide numerator and denominator by 3. So this would be 5 pi over 2. We'll go ahead and do one more. We'll do 315 degrees. So 315 degrees times the ratio, as before, pi over 180. The degree units cancel. We could divide top and bottom by 15. 15 goes into 315 21 times. And 15 goes into 180 12 times. So 21 over 12. But those are both divisible by 3. So this would be 7 pi over 4. And if you are familiar with the unit circle, you can confirm any of your answers that you find if the measurement is from the unit circle, just to check your answers. Okay, next we're going to look at arc length. Arc length is a distance around the circumference of a circle. So it's kind of like the perimeter of a quadrilateral or any other polygon, but we're just looking at a circle which doesn't have sides, it just has the entire circumference. So to calculate this, I have a formula here we're going to use, which is this one right here. Arc length, or S, equals r times theta. The only catch is your angle has to be in radian. Okay, so if we are given a measurement of an angle that's not radian, we can convert first, and then we can just use our result. So we'll start with number 13 here. Very simple problem. It says, find the arc length of the following. We have a circle that has a radius. Right here, this is the radius. So our radius is 13 inches. And the angle is pi over 6, so that's our theta. It's already in radian measure. So we could just apply our formula. S equals r times theta. So this would just simply be S equals 13 inches times pi over 6. So our arc length would be 13 pi over 6 inches. So if you're given a radius and an angle in radian, that's how simple this formula is. Okay, number 15 here. We're just given the circle, very obviously giving us a radius of 11 feet. So that's our radius. The angle they give us is not in radian. So theta is 315 degrees. So we're going to do a little conversion, just like in the previous few problems we started with. To convert this to radian, we're going to multiply by pi over 180 degrees. The degrees cancel. And I believe this is the one we found that if you reduce that fraction, 315 over 180, you get 7 over 4. So this is 7 pi over 4 radians. So to use our formula, this would be S equals r times theta, which would be 11 feet times 7 pi over 4. We would get the arc length S equals 77 pi fourths. And that would be in a unit called feet. So if you have to round your answer, you could pop that into Desmos or any other calculator you would use, and 77 times pi divided by 4 would be the answer. And we'll end with number 16 here. What is the central angle of an arc length of 24 pi inches of a circle with radius 16 inches? What is the measure of the angle in radian and degree? So we're given the arc length and the radius, but not the angle measurement. So we'll just go back to our formula, S equals r theta, r times theta, and just plug in what we're given here. So our new formula, or what we have now, is arc length, so 24 pi, equals the radius, 16 inches, times theta. Okay, so we divide both sides by 16, and we're just left with theta. Now there's no degree units anywhere, so this is a radian value. So 24 over 16 is 3/2, so that's 3 pi over 2. So the answer in radian measure is 3 pi over 2. At this point, if you know your unit circle, you would know the degree measurement for this, but we'll go ahead and just convert it just to show one more time that we can do this conversion. So in degrees, we have 3 pi over 2 in radian, and we're just going to multiply by 180 degrees over pi. The pi's cancel. 180 divided by 2 is 90. So this is 3 times 90 degrees, which is 270 degrees. So the angle would either be 3 pi over 2 radian or 270 degrees. I hope that helps you a little bit with converting between radian and degrees, as well as looking at arc length. Thanks for watching.